All right, 9.6, equations or equation of a circle. We're going to actually learn how to graph. So, objective, Buckingham students will be able to write the equation of a circle given the coordinates of the center and its radius, and also you should be able to sketch it from its equation. We're going to do a little discovery activity, and we're going to do this more in class, but I'm going to kind of do this briefly so you kind of understand what we do in class when we work on Desmos. It says, let's just try and do this. I would like for you, before I do all this, I would like for you to pause this video and try to do all this on your own in the notes, okay? If you can't, if you get stuck or whatever, then come back and unpause the video and watch it. But I want you guys to just try it and see what you think, okay? Give it a shot first. So I'm going to pause it now. Okay, hopefully you gave it a try, but let's do it together now. All right, suppose you have a circle with a center at 0, 0. So here's the center at 0, 0, and a radius at 5. All right, so I'm going to sketch that real quick. Okay, so it looks something like that. I just paused it, did it quicker. There's my circle. Graph this scenario with the radius drawn somewhere in the first quadrant. So we're going to draw out or sketch a radius to some point like that, okay? And we know that this radius is 5 because it's a circle with a radius of 5. All right. Number 2, with the radius as the hypotenuse, draw a right triangle with one of the corners at the center of the graph. Okay, so one of the corners at the center of the graph, this is the hypotenuse. So a right triangle that we could draw would look something like this, right? There's a little right triangle. All right, now it says, now use the Pythagorean theorem to write any equation for any point on the circle P with coordinates x, y. Now this is where you might get a little confused. So let's call this P here. And we'll say that it has coordinates x, y. So thinking about this as Pythagorean theorem, this is what I want you to kind of realize. If this is just point x, y, wouldn't this distance over here just be x, and this distance up and down just be y? If that's true, we can write an equation for any point on the circle using Pythagorean theorem. We could say that x squared plus y squared will always equal 5 squared. There we go, we've done it. Any point on there. And the reason why we know that that's x and that's y is kind of like, isn't this point 0, 0? And at this point, we could actually come up with the coordinates of this point if you think about it, because it's the same distance over x as this point. So this would be point x, comma, and it's not going up or down at all, so this would be x, comma, 0. And so what's the distance from x0 to 0, 0? Well, it's x. And what's the distance from y to 0? Well, it's y. Okay, so we got our equation. Now let's talk about number 4. Now, suppose the center was not at 0, 0 and was at another point like 3, 4, for example. So now let's put the center here and let's draw a circle with that as my center. Okay, we're just playing with this a little bit, so I'm going to pause it and make a quick sketch of that circle. Okay, so I tried to draw a circle as best as I can there. So there's a circle now with the center at the point 3, 4. All right, so that's what they wanted me to do. How might this equation be different? So let's do this now. We're going to have some other point on this circle. Let's make it over here now, and maybe we'll call this Q now. And this point is just going to be some x, some y, meaning we have some point here. So let's do the same thing we did before. We drew a hypotenuse in, and we drew in this side, and we drew in this side. Maybe I rewrite the 3, 4 over here so I'm not covering it up. And we could actually, again, we could think about what this point here would be. What would this coordinates of this point be? Well, I went over 3, and then I went over another some distance that we don't know to get to x. So I'm straight down from x here, so this coordinate would just be x. Right? I didn't go, I don't know how far over I am total, but I know that I'm over x units total. Now, I didn't move to the left at all, left or right at all from this point here. So the y value is the only thing that's going to change. So it's going to be the same as the y value here because I didn't move up or down at all. So if this is 4, then this is 4. Okay, sorry, it's a little jumbled, but hopefully we can get there now. This radius is still 5. So this radius is still 5. I know it's getting real messy here. So we have this distance that's 5. Could we come up with an expression for this distance and this distance so we can use the Pythagorean theorem again like we did here? Okay, that's what the whole point of this is. Now, if this is 5, couldn't we say that this distance here is x, because we know that this whole distance is x, minus 3, right? So this is x minus 3, because here I'm at x, here I'm at 3, so the difference must be the distance, x minus 3. And in the same way, this distance must be the difference between y, because we know that this height is y, and 4. So this one must be y minus 4. All right. I know it's a little bit jumbled. If I was to redraw the triangle over here, it would look something like this. We know we have a 5. We know that this is y minus 4, and this is x minus 3. All right. That was all just so we could go down here and write that equation. That equation would be, if we plug it into Pythagorean theorem, would be x minus 3, whatever that is, squared, plus, parentheses, y minus 4, whatever that is, squared, equals 5 squared. All right. Now, you could break that down, you could expand it and simplify it, but that's not what we're really worried about here. Next thing says, what if we don't know the center and use the coordinates hk as placeholders? How would we write the equation then? Well, this is the thing that I want you to see. When the center here for the red circle was at 3, 4, the 3 ended up here, the 4 ended up here, and that's always going to be the case with circles. That's the point of this. So maybe instead of writing x minus 3, if that's my x value of my center, I could just write x minus h squared, because it's what it's going to be if we just follow the same pattern. And in the same way, we could say plus y minus, now my y value of my center is now k. So I could just write y minus k squared. And if the radius was still 5, it would be 5 squared. But what if we didn't know the radius at all? What if I just said, hey, you know what, the radius is unknown, so we're going to call it r. Well, wouldn't this just be r squared? Okay. Now, if you don't get the whole explanation of where this formula came from, don't worry. We're gonna definitely spend more time with that in class. But we just found the general equation of a circle. And so we're going to talk about how we can use that on the next page. And hey, look, what do you know? That's the equation we came up with, right? It's the equation of a circle. So now we're going to use this to kind of answer some problems that we might see. Here's an example of one. It says write the equation for a circle with a center at -2, 4 and a diameter of 4. Okay, so this is the part where even if the last part was confusing to you, this part is so easy. Check it out. If the center is at -2, 4, then we could say that h is the -2 and k is the 4. And if the diameter is 4, we can also find out what the radius is, right? It's just going to be half of the diameter, so that's 2. Well, now we just plug it in and we're done. Check it out. We're going to write x minus, what's the h value? -2 squared plus y minus, what's the k value? It's 4 squared equals, the radius is 2 squared. All right, and all we're going to do is just kind of simplify this a little bit in that instead of writing x minus -2, couldn't we write x plus 2 squared plus y minus 4 squared equals 4? That's it. We're done. We have written the equation of the circle. That's all they want you to do here. A little thing to remember is if this is positive, since the formula is x minus and y minus, if this is positive, then the center is going to be negative, right? It's always going to be the opposite. That's just a little rule that you might want to remember. Okay, so here's one you could practice. It says, practice number 1, write an equation for a circle with a center at the origin and a radius of 3. Go ahead and give this one a shot on your own. Okay, so hopefully you saw that the origin is at 0, 0. So you do, that's your h and that's your k, so you could do x minus 0 squared plus y minus 0 squared equals the radius squared, which is 3. So that just simplifies down to this. Kind of neat. All right. In example number 2, we definitely have kind of a logic question here for you. It says a circle with a diameter of 14, so right away, if it has a diameter of 14, I'm going to just make a note. That means we have a radius of 7, right? Has its center in the third quadrant. In the third quadrant. Okay, well, for quadrants, remember, this is 1, 2, 3, 4. So it's somewhere here. We know the center is somewhere here. The lines y equals negative 1. Okay, y equals negative 1 is right here. Let's go ahead and graph that. And x equals 4. X equals 4 right here. This is all the places where x is 4. It's right here. Are tangents to the circle. Oh, okay, so they're tangents. Well, remember we learned that tangents are always perpendicular to the radius. So if we're somewhere in this third quadrant, we know that we're going to go down from this line and to the left of this line. So we could start either one, it doesn't really matter. Let's start by going down, straight down, because remember, radii are perpendicular to tangents. So we're going to go straight down 7. So let's just use some red to count. And I'm just picking some arbitrary point to start from. So 1, 2, 3, 4, 5, 6, 7. So my center is somewhere on this line. Well, I also know not only is it going to be perpendicular to this line, it's going to be perpendicular to this line, and now I know what line it's on. So I can go to this line, start here, and count. 1, 2, 3, 4, 5, 6, 7. So right there, that's the center. So there we go. And we could double check that real quick. Just count again. We go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep, there's the center. So what do they want me to do? Write an equation to the circle. Well, we could sketch the circle if we wanted to real quick. It won't all fit in this graph, but we got an idea of kind of what it looks like. I'm going to not cover up the summary, but there's a circle, but we want the equation to it. Well, remember, to find the equation, we need the center. We need the coordinates of the center, which we know. We know what the center is because we go back 3. So this is at negative 3. And we go down 1 and then another 7. So that's down 8 total. So this is negative 8. You could count it if you want. You could just go 1, 2, 3, 4, 5, 6, 7, 8. So that center is at negative 3, negative 8. So let's just write that real quick. So there's my h, there's my k, right? So if I go to write out the formula, remember the formula is x minus h squared plus y minus k squared equals r squared. Well, my h is negative 3, so I got a double negative. And my y is negative 8, so I got a double negative there. And my radius is 7, so we could clean this up. It would be x plus 3 squared plus y plus 8 squared equals 49. Boom. Okay. So we've talked about writing the equation, and graphing it is pretty simple. All you do is you just plot the center and then figure out some points that are, your radius away from the center, and then kind of just sketch a circle around those points. So for the summary, what I want you to do is I want you to describe to me how you would graph the following circle as if you were explaining to someone who had only a basic understanding of the coordinate plane. So you have an equation here, so you should figure out what the center is, you should be able to figure out what the radius is, and explain how you could put that onto a graph. Remember, you're explaining it to someone like maybe that's in junior high or something like that. All right. See you guys on the next video.